Good day. Today we're going to deal with the type of question that says, for which values of x will x times h at x be less than 0? So this question usually comes out in the hyperbola, but we're going to deal with it first in the parabola. If you're interested in similar videos, the playlist of this type of questions is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. So let's begin. Alright, here is the first question. So it says, for which values of x will x times f at x be less than 0? So in the graph, g is the straight line graph and f is the parabola. So every time you've got this type of question, where you've got x times either f at x or g at x or h of x, what you will do is that whenever there is x, you will draw a vertical line on the y-axis. And then with this part, f at x, you will draw the vertical line on the x-intercepts of f. If it was h at x, you would draw vertical lines on the x-intercepts of h. If it was g at x, you would draw vertical lines on the x-intercepts of g. So in this particular case, we are interested in the x-intercept of f. So f is the parabola. So its x-intercepts at this point and this point. So we have to draw vertical lines that pass through the x-intercept. So we'll draw vertical lines over there. So we have a total of 3 vertical lines. These 3 vertical lines separate the whole Cartesian plane into 4 parts. Because we've got group 1, we've got group 2, we've got group 3, the small group, and then finally we've got group 4. So, according to the question, we want the multiplication signs to give us a negative. How do we know that it's negative? For instance, in the textbook, whenever they tell you a is greater than 0, they are indirectly telling you that it's positive. They don't like writing it in words. Or if they say a is less than 0, they're indirectly telling you that a is negative. They don't like writing it in words. So it means that we want their multiplications, the product, to give us a negative. So how do we get a negative result? We get negative whenever it's positive times negative or negative times positive. In other words, if x is positive, f at x must be negative, or if x is negative, f at x must be positive. Alright, so now let's check each group and find out whether they fulfill the requirements. So let's check group 1. So first of all, I'm going to explain this part, then I'm going to explain this part. So dealing with this part, whenever the graph is above this blue line, the x-axis, the y value is positive. It's positive because it's on the positive side of the y-axis. Whenever the graph is below the blue line, then the y value is negative. It is negative because it's on the negative side of the y-axis. So, talking about this part, notice this is the positive side of the x-axis, this is the negative side of the x-axis. So, with this part of x, you have to check the x-axis because it's literally written x. So, you have to check whether it is on the positive side of the x-axis or whether it's on the negative side of the x-axis. So, let's check in group 1. Let's check f at x first, then we'll check x. So, for instance, in group 1, looking at this part, we can see that the y value of f, because f is the parabola, the y value of f is below the blue line. And because it's below the blue line, it means that it's negative. And then now we have to check this part. We have to check, is it on the positive side of the x-axis or on the negative side of the x-axis? Well, this part is obviously on the negative side of the x-axis because it's on the left of the y-axis. So, therefore, we've got negative and negative. Does it fulfill the requirement? No, it doesn't, because we want them to be different. And then let's find out in group 2. So in group 2, the y value of f is positive because it is above the blue line. It is on top of the blue line. So the y value of f is positive. Now let's check the x part. Is it on the negative side or on the positive side? Well, it's still on the negative side of the x-axis, right? It's still on the negative side of the x-axis because it's on the left side of the y-axis. So therefore we've got positive and negative. Does it fulfill the requirement? Yep, it does fulfill the requirement because we wanted them to be different. So let's check this little group over here. So Obviously, if group 2 fulfills, group 3 will not fulfill, but let's just verify. So the y value is still above the blue line, right? The y value of f is still above the blue line, so therefore the y value of f is positive. What about the x-axis? Is it on the positive side of the x-axis or the negative side of the x-axis? Well, if you look at the x-axis, like the x values literally, you see that they are now on the positive side of the x-axis because they're on the right side of the y-axis this time. So they're to the right. If they were to the left, they would be negative. So does it fulfill? No, it doesn't, because we've got same signs. We've got positive and positive. So it does not fulfill the requirement. Now let's check the final group. Obviously, if the previous group did not fulfill, the next group will fulfill, but let's just verify. So this time, the y value of f is underneath the blue line. So therefore, it means the y value of f is negative. And then what about the x-axis, since we have to check this part? So what about the x-axis? Well, the x-axis is positive, right? Because it's on the positive side, right? The x values are positive rather because it's on the positive side of the x-axis. So we've got negative and positive. Does it fulfill the requirement? Yes, it does fulfill the requirement. So we wanted them to be different. So now we have to describe group 2 and group 4. So let's describe them. So I'm going to describe them in interval notation first, then I'm going to describe them also in inequality notation. Then you can choose your preference. You'll do good to know both of them so that you can play around with them. So since it was group 2 and group 4 that worked, we have to describe them. Let's describe group 2 first. So if you look at the x values, where does it start and where does it end? So group 2 starts from -5 and it ends at the y-axis, right? Which means the x value is 0. So it starts from -5, it ends at 0. So we'll say x is an element. So we'll tell them it starts from -5 and it ends at 0. Now let's talk about the brackets. Will it be square or curved? It depends on the question. If the question says less than only, then it means it will be curved. But if the question says less or equals to, then it means we'll have square brackets. But because of the question in this case, we'll have curved brackets. So then now we're describing another group. So we will say, oh, so now we don't say it in words in interval notation. We have to write it like in probability. So now let's describe the fourth group. So where does it start? Where does it end? So it starts from 1 and it ends, it has got no end, right? It starts from 1 and it has got no end, meaning that it ends at infinity. So we'll tell them that it starts from 1 and then it ends at infinity. So now let's talk about the brackets. Infinity always has a curved bracket, irregardless of the question, whether it says less than or whether it says less or equals to. And then this part will follow the question. If the question says less than only, it means it will be curved. If it says less or equals to, it will be square. So because of the question in this case, we'll literally have curve. So now I have described it in interval notation. Now let me also describe it in inequality notation, just in case some students prefer inequality notation. So with group 2, where does it start? Where does it end? So it starts from -5 and it ends at 0. So whenever it has a beginning and an end, you'll always put the x value between. So you'll say it's between -5 and 0 because it starts from -5 and it ends at 0. So whenever it has got a beginning and an end, you put the x values between. And then the signs will always be facing this way. They will never face that way whenever the x value is between. So it will always face this way. And then if the question says less than only, you leave it like this. But if the question says less or equals to, you just copy the question. You just put it like this. So it will always be facing like this. Even if the question says greater than, you'll always have inequality signs facing like this whenever x is between. And then now in inequality notation, we say or in words. So now let's describe this group, because it was the other group that worked. So it starts from 1 and it ends at infinity. So it has got no upper boundary, it has got no end. If it has no end, it means it can become as large as possible. So therefore, you'll say x is greater than 1 because it can become as large as possible. It has got no upper end. If it was group 1 that you were describing, let's just say group 1 was the one that worked, you would notice that it has got no beginning, but it has got an end, meaning that it can become as small as possible. So the arrow points to the left. So whenever the arrow points to the left, you will just simply say x must be less than -5, because it can become as small as possible than -5. So whenever you are describing group 1, notice that this arrow points to the left. You will just simply say it's less than. But whenever you are describing the last group, you would notice that the arrow points to the right. So hence you will say it's greater than. So that is how you describe it in both interval notation and in inequality notation. So let's proceed to the next level. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. Alright, here is another question. So it says, for which values of x will x times h at x be greater than 0? So in the hyperbola, there's something a little bit different that is done here. So first of all, we look at this as normal. We know that when you see h at x, we have to focus on the x-intercept of h. So the x-intercept of h is the hyperbola, as you can see. So h is the hyperbola. So this graph has only one x-intercept over here. And we draw a vertical line that crosses the x-intercept of that graph. So when we look at x, we know we have to draw a vertical line through the y-axis. So we could say we have two vertical lines that separate the whole Cartesian plane into 3 parts. But there is something different here. Whenever it's a hyperbola, we have a vertical asymptote. Whenever we have a vertical asymptote, we also have to draw a vertical line through the asymptote. So it is a must. Whenever you've got a hyperbola, make sure you draw a vertical line through the vertical asymptote. So we have got group 1, we have got group 2, we have got group 3, and finally we have group 4. So now we have to check which group fulfills the requirement. So we want the multiplication signs to give us positive. So it means there must be positive and positive, or negative and negative. So they must be the same. So we have to check the x value. We have to find out whether it's positive or negative. So in group 1, the x value is negative because it's on the negative side of the x-axis, right? It's on the left side of the y-axis. So it is negative. So now let's check the y value of h. The y value of h is the hyperbola. Notice that the graph is above the blue line. So it's above the x-axis. So because it's above the x-axis, it means that it is positive, right? Because it's on top of the x-axis. So we have got the multiplication signs being giving us a negative because they're different, and we wanted them to be the same so that they can give us a positive. So let's check the y value of h. So notice that h is the hyperbola, and in group 1, h is above the blue line, right? So because it's above the blue line, it means the y value is positive. So does group 1 fulfill the requirement? No, it doesn't, because the signs are different. We wanted the signs to be the same. So now let's check group 2. If group 1 doesn't fulfill, obviously in group 2 it will fulfill, but let's verify. So in group 2, notice that the x value is negative. The x value is negative because it's on the negative portion of the x-axis. So we have the negative x value, and then let's check the y value of h. So now notice the y value of h is negative. It is negative because the graph is now below the blue line. It's underneath the blue line, so the y value is negative. And let's check now. Notice that the signs are the same this time as we wanted, so it fulfills the requirement. So if group 2 fulfills, group 3 will not fulfill, but let's just verify. So in group 3, let's check the x-axis. So now it is the positive portion of the x-axis, right? It's on the positive side. So the x-axis is positive. And then let's check the y value of h. So the y value of h is negative because it's underneath the blue line. So it's on the negative side of the y-axis. So we conclude that it does not fulfill. Now let's check the final group. So in the final group, let's check the x value. So the x value is on the positive portion, right? The positive portion of the axis. So it is positive. And then let's check the y value of h. So now notice h is on top of the blue line, so meaning that it has got a positive y value. So does it fulfill? Yes, it does fulfill. So it does fulfill. So group 2 and group 4 was what worked. So I'm going to describe it in interval notation and also in inequality notation. So let's talk about group 2. Where does it start? Where does it end? So group 2 starts from -8 and it ends at the y-axis, meaning that x is 0. So it starts from -8 until 0. So we'll tell them that x is an element of -8 until 0. And then let's talk about the bracket. So because of the question, we see that it says greater than only, it means it will be curved, right? But if it says greater or equals to, then it means we would have it as square. But now, because of the question, we leave it as curved. So now let's describe this portion as well. So it starts from 1, right? Because the asymptote is 1. So it starts from 1 until infinity because it has got no end. So we'll tell them we'll say, it starts from 1 until infinity. Infinity always has a curved bracket. Now this says greater than only, so meaning that this part will be curved. If it says greater or equals to, we would have it as square. So we literally have it as curved. So I have described it in interval notation. Let's also describe it in inequality notation. Just before I describe it in inequality notation, if you're interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details just in case these ones have changed is found at the end of this video. So this group, notice that it has got a beginning and an end. So it starts at -8, it ends at 0. So we'll put x between. Every time it has got a beginning and an end, we'll put it between. We'll tell them it starts from -8 until 0. So we know that the signs are always going to be facing that side. So the inequality signs are always going to be facing this way, right? So we have to check the question. If the question says greater or equals to, we would put equal signs as well. But since the question says greater than only, it means we leave it like this. Then we'd say or in words. Now let's describe the final group. So notice it starts from 1 until infinity. So it has got no upper end, meaning that it can become as large as possible. And the arrow points to the right. So it can become as large as possible. So we'll say x is greater than. So notice it starts from 1. So we'll say x is greater than 1. So there we have it. That's how we describe it in interval notation and also in inequality notation. There we have it. So this brings us to the end of the video. If you enjoyed the video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to make, please comment below. See you in the next video.